Hello everybody. Today what I'm going to do is we're going to review the quantum numbers. As you see in the chart, there are 4 quantum numbers that describes the organization of electrons in the atom. If you remember, the first quantum number is called the principal quantum number, and it's designated with the symbol N. N can equal 1, 2, all the way up to 7. Now, hypothetically, it could go further. It can go to the 8th. But as of now, we've only had 7 energy levels discovered, so N will go up to 7. If you recall, energy content increases as you get further away from the nucleus. Now, every quantum number is divided into an orbital quantum number, and that's the second one, symbolized by the letter L, where each designation represents one of the orbitals. For instance, if L is equal to 0, that represents an s orbital. If L is equal to 1, that represents a p orbital. Again, if L is equal to 2, it represents a d orbital. And if L is equal to 3, that represents an f orbital. Hypothetically, if there was a g orbital, that would be L is equal to 4. Now, the third quantum number describes how many possible orientations each orbital can have. For instance, the s orbital only has one orientation, and the symbol for the third quantum number, which is known as the magnetic quantum number, is m sub L. If you recall, since the s is a sphere, it only has one orientation, and the designation, the ml value for that, is simply 0. The p orbital can be graphed 3 different ways. One is known as px, then there's a py and a pz. And since there are 3 orientations, the ml values for each is -1, 0, and +1. The d orbital has 5 possible orientations, and the designations for each of the 5 would be -2, -1, 0, +1, and +2. And then we get to the f orbital, which has 7 possible orientations, so the designations are -3, -2, -1, 0, +1, +2, and +3. Hypothetically, a g orbital would go from -4 to +4. Now, the final quantum number is known as the spin quantum number, which is symbolized by the ms symbol. And the rule is that there could be a maximum of only 2 electrons per orbital. However, they must have opposite spins. This is why this is known as the spin quantum number. The ms symbols are as follows. 1 electron spinning clockwise gets the +1/2 symbol, while the other electron going counterclockwise gets the -1/2 symbol. So these are the 4 letters N, L, ML, and MS that are used to designate an electron inside an atom. These are known as the 4 quantum numbers. So here's what we're going to do. There's a principle called the Pauli exclusion principle, and we can use these 4 letters to give the electron an address. And according to the Pauli exclusion principle, no 2 electrons can have the exact same 4 quantum numbers. In other words, no 2 electrons within the same atom can have the identical address. They all have something different. One of the 4 quantum numbers would be different. So, here's what we're going to do. We're going to go ahead, I'm going to erase this part here. And what we're going to do is, I'm going to give you a sample of how to determine the address to an electron. And what we're going to do is, we'll start with a very simple one. We'll start perhaps with lithium. Okay? Lithium, the electron configuration is 1s2, 2s1. Lithium only has 3 electrons in total. The orbital notation for lithium would look like this. You would draw one S with a box, and you would draw one arrow going up, one arrow going down. And then you would go to the 2S, and that would be just one arrow going up. This would be the orbital diagram of lithium. Now, suppose we want to get the address to the electron that is circled. Here is how you would do this. The address consists of these four letters, N, L, ML, and MS. So in order to get the address, what you do is the N value is the energy level. Right here, you look at that coefficient. That tells you that that electron is in the second energy level. So N is equal to 2. The L value is the orbital. It is in an S orbital. Therefore, the L value for S is 0. Now, the ML value is the orientation. Now, the S only has one possible symbol, and that would be a 0. S only has a 0. And since the electron is pointing up, we're going to assume it's going clockwise. So the designation would be plus a half. That electron that is circled has the following address. Okay? Now, let's suppose that we take another element, and we'll say the element is, let's make something a little bit bigger here. How about aluminum? Aluminum has 13 electrons, so the designation is 1s2, 2s2, 2p6, that's 10, 3s2, and then it's 3p1. Okay? Now let's get the address for this last electron. Now recall, 3p, if you do an orbital diagram for the last one, you do 3 boxes, like this. And using Hund's rule, you put the electron there. So let's say I wanted to get that electron. Here is how you get the address. Well, it is in a 3 energy level. So N is 3. The L value would be, it's in a p orbital. And the value for p is 1. The ML value is, this is the way you would do this. The first box would be the -1/2 designation. The middle box is the 0. And this would be the +1. Remember that P has 3 orientations. And it goes -1, 0, +1. So if you notice, since he's in the first box, the ML value is -1. Whereas the MS value, the electron's pointing up, meaning spinning clockwise, it's +1/2. And that's how you would designate the electron, that last electron there for aluminum. Now let's try one more. Okay? And this last one, what we'll do is we'll take, let's say, we'll look at nitrogen. Nitrogen is number 7, which is 1s2, 2s2, that's 4, 5, 6, 7. Okay? The orbital diagram for this would be 1 up, 1 down, then you got another 2s here, 1 up, 1 down. Then when you do the 2p, you do 3 boxes, and you go 1, 2, 3. So, if I wanted to get the electron circled here, it would go as follows, okay? The N value would be 2. It's in the second energy level. The L value is in a p orbital, so it's 1. The ML value, if you recall, this would be -1, this would be 0, this would be +1. It's in the last one, so you put +1, and then it's pointing up, so the MS value would be +1/2. Now, let's suppose that we wanted to get the electron. I wanted to know the address of this electron over here. Okay? So, let's go ahead and do that. If we were to get that electron, it would look like this. The electron is in the second energy level. It is in an s orbital, so the L value is 0. The ML value, because there's only one orientation for S, would be 0 as well. And the MS, since it's pointing down, it would be -1/2. Okay? So if you recall, the 4 quantum numbers are used to designate the location or the address of an electron within an atom. And according to the Pauli exclusion principle, no 2 electrons can have the exact same address if they are within the same atom. Okay? We will follow this up with an assignment where we're going to use quantum numbers to designate electrons. Okay? I hope everybody has a wonderful day.